Hi, I'm Zack Strater, and today I'll be talking to you about my project Pitch Perfect AI, where I use deep learning to transcribe music from audio. So why music transcription? The problem here is that it's very difficult for casual musicians to learn new songs. Either you have to learn them by ear, which is very difficult, or you have to try to track down reliable sheet music, which can often be a very small selection. So here I'm proposing a machine learning approach to this problem. Can we train an AI to listen to music and automatically transcribe it into a written form? So here you can see traditional written form would be sheet music. The one I'll be dealing with in this project is often referred to as either piano roll or MIDI, which just shows which notes are being played at what times. So the data set I'll be working with for this project comes from the Maestro database. It's about 200 hours of classical piano recordings over 10 years from an international piano competition, and it contains synced audio and MIDI files. Some difficulties with this data set is that there's varying qualities between the recordings and different noise levels. And another problem is that some of it is very musically complex, so it could be difficult for a machine learning model to learn. So the machine learning approach I took to this, I asked myself, how does a machine learning model listen to music? And what I came up with is actually it's probably easier to train it to see music instead. So that way we're essentially reframing it as a computer vision problem. And one really advantageous uh, thing about this reframing is that we get to use convolutional neural networks. So these are one of the most powerful tools in the machine learning arsenal. They're very good at parsing 2D and 3D data, and they basically learn by scanning images with these windows, and they can look at all of the images and extract features from them. So how do we get music into a visual representation, basically an image? And basically we can do this by taking the raw wave file and we can convert it into the audio waveforms. This is essentially what a wave file looks like, graphed out. Um, and then we can do a Fourier transform on it. So this is a mathematical operation that scans through this whole waveform and looks at every moment in time what frequencies are being played at that time. And so we get this 2D plot with time on the x-axis, and on the y-axis we can see what frequencies are actually being played. And you can see that there's a lot going on here, and the reason is that musical notes are pretty complex. They contain a lot of harmonic information than you might realize. So the target data that we're trying to predict here is MIDI data. And basically we want to guess what notes are being played at what times. So the way that I constructed this target data is by taking the raw MIDI files, parsing it into a list of strings that contain all the information for when the notes play and stop playing. And we can take that information and actually populate a 2D array that matches the audio file. So here you can see a matched audio and MIDI file. And the approach I took to this was I took those matched files and I sliced them into equal partitions. And what I had the model train on is it would look at a window of audio and just try to guess one single slice in time what notes are being played. So you can see this red line representing the slice that it's predicting. And you can see that some situations are pretty simple. You can actually sort of map on the audio window to this MIDI window over here, and you can kind of correspond the notes to each other. And here it needs to just guess one note right, but over here it's a more complex example where it's needing to guess about 10 notes at a time. So this is why this problem is fundamentally a multi-label classification problem. So basically all 88 notes are available to be guessed at for every prediction, and it has to decide, the machine learning model has to decide which notes it thinks it's being played at that moment. So for this, to build my model, It's a mixture of convolutional layers and max pooling layers, eventually being flattened out to a final 88 nodes. Those 88 nodes correspond to the 88 notes on a piano. And here we're using binary cross entropy with a final sigmoid activation layer, and that's how you can do multi-label prediction with neural networks. So evaluating the model. So first I just did a baseline model, giving it 10 units to look to the left and 10 units to look to the right for the audio window. And precision here describes when the model is making a guess, if a note exists there or not, how often is it right, and the recall is essentially the total amount of the notes that it guessed correctly. And the F1 score is a harmonic average of the precision and recall, and it is the best evaluation metric, in my opinion, for this model. So you can see here, we get an F1 score of 0.33. If we extend the window left, we actually can increase the F1 score. But if we extend a window right, so essentially letting it see forward in time, it actually only provides marginal utility for the model. Interestingly, removing the effects of the sustain pedal were very bad for the accuracy of the model, and giving the audio windows more frequency bins, so basically making a higher resolution image, made the model also a little better. So in conclusion, during this project, I trained a convolutional neural network to predict MIDI notes from piano audio, resulting in a 0.39 F1 score. And here you can see an actual prediction of a very simple case where it's just playing a C scale up and down, and you can see that it does a pretty good job at predicting the notes. Future work on this project, I want to implement a second convolutional neural network that will take output like this and essentially stitch together the notes to make it sound more realistic. I also want to explore more complex neural network architecture. And eventually I would like to get to a point where instead of just predicting a slice in time, I'm actually predicting the entire window. So yeah, that is my project, Perfect Pitched AI. Thank you for listening.